Welcome to another deep dive. We're going to be talking about quantum reinforcement learning today.
Oh, cool.
It's QRL for short.
Yeah.
And we're going to be looking at this essay from Jurgo Schneeppert called QRL, Quantum Reinforcement Learning for Intelligente KI.
Okay.
So this is going to be really interesting. I think that this essay is going to give us a really good overview of QRL, where it came from, where it's going, some of the problems, and yeah, some of the potential.
So basically where it is right now and like what we can look forward to.
Exactly.
Okay.
Yes. So what we really want to do with this deep dive is to give the listener a really solid understanding of like what QRL is.
Mm-hmm.
Not just like what it is, but also like why it is and like, so what?
Yeah, exactly.
Like what are the implications of all of this?
Yeah, so starting with kind of just like the basics.
Right. So I guess the first thing that we need to talk about is like what even is reinforcement learning?
Yeah.
So we can call that RL. So just regular RL before we even get to the quantum part of it.
Reinforcement learning is, I guess like a good way to describe it is like training a dog with treats.
Okay.
So they do something good, you give them a treat, and the more they do the good thing, the more treats they get. And so they start to associate that good thing with getting the reward. So it's basically an agent learning to make optimal decisions in an environment to maximize rewards.
So is the agent the dog in that example?
Yeah, exactly. So that's kind of how it works.
And so then the environment would be like wherever the dog is.
Yes.
Okay, that makes sense.
Yeah. So then to add on the quantum part to that?
Yeah. So what makes this quantum?
Well, it's like adding on quantum computing, basically.
Okay.
So instead of using normal bits, we're using qubits.
Okay.
And those can be, in superposition. So that's like being in two states at once.
Right. Yeah.
Entanglement is like spooky action at a distance. They're connected no matter how far apart they are. And then also interference.
Right.
Where it's like a wave and they can interfere with each other.
So how does all of this quantum stuff that is happening, how does that actually make reinforcement learning better? Like, why are we adding the quantum to it?
Right. Well, the biggest part of it is because with a quantum computer, you can run multiple possibilities at the same time.
Okay.
So it's like tasting all the ingredients of a dish at the same time instead of one at a time.
Okay, that makes sense.
So you're able to explore all the possibilities simultaneously.
So would that be kind of like the dog is now tasting all the treats at the same time?
Yeah, exactly.
And can figure out which one it likes best?
Yeah, exactly.
Especially faster.
Yeah, so it can learn a lot faster. And so that can be applied to like all sorts of problems.
So Schneeppert talks about logistics as one example of this.
Yes.
How would quantum reinforcement learning be used for logistics?
So, with a delivery company, for example, they're trying to figure out what's the most efficient route for all of their delivery people to take.
Right.
And so with like a normal computer, they would have to go through each route individually.
Yeah.
Calculate how long it would take.
Okay.
But with a quantum computer, they could calculate all the routes simultaneously.
Wow.
And consider things like traffic or weather and even fuel efficiency all at the same time.
Okay.
To figure out what is the absolute best route to take.
So it's like the quantum computer is considering like every possible scenario at the same time.
Yeah, all at once.
Wow.
And so it can come to a conclusion much quicker.
And Schneeppert even mentions Grover's algorithm, which I know is a quantum algorithm.
Right, yeah.
That I guess is like a specific example of how you could use a quantum computer to do this.
Yeah, exactly. That's one that you can use. And he also mentions optimizing resource management.
Okay.
So that could be like data centers.
Okay.
Trying to figure out like what is the best way to use energy.
Mm-hmm.
And so they could use quantum computing and QRL to do that.
Yeah, so we've got these two examples, logistics and data centers.
Mm-hmm.
What other potential applications does Schneeppert talk about in his essay?
He talks about autonomous systems.
Okay.
So like a self-driving car, for example,
Okay.
could use QRL to be able to not just react to its surroundings, but also learn from past experiences and predict future scenarios.
Okay.
So it's basically like...
So it's like a car that's constantly learning as it's driving.
Exactly, yeah. And it's using quantum computing to do that.
Okay.
So it can process all that information so much faster.
And so that would make the car like a better driver over time? Is that the idea?
Yes.
Okay. Yeah.
The car would be able to adapt and learn from its mistakes much faster.
Okay.
Yeah, so it could lead to safer and more efficient transportation.
Okay, that's really interesting.
Yeah.
So we've got logistics, we've got resource management, and we've got autonomous systems.
Mm-hmm.
What else does Schneeppert talk about?
He also goes into scientific simulations.
Okay.
So, like, a big one is drug discovery.
All right.
So, to develop a new drug is like a super long and expensive process.
Right.
And so, what scientists could do is use QRL to simulate molecular interactions at a quantum level. And that would allow them to figure out which drug would be the most effective
Okay.
and have the least amount of side effects.
Wow. Okay.
So that would be a huge breakthrough.
So you're saying that you could like design a drug
Yeah.
and then like simulate how that drug would interact with the body
Exactly.
before you even give it to somebody.
Yes. And that's just not possible with classical computers. It's just too much information.
Okay.
But with quantum computers, it could become a reality.
So we've got all this potential.
Yeah.
It's super exciting.
Yeah.
So then why isn't this everywhere?
Right.
Why isn't everybody using this? What are some of the challenges that are holding QRL back?
Well, Schneepat actually talks about this in his essay. One of the biggest challenges is the technology itself.
Okay.
Quantum computers are very difficult to build, and they're also not very stable.
He even makes the comparison, doesn't he, to like old computers?
Yeah.
Like the room-sized computers
Yeah.
that were around, decades ago.
Exactly. So they're like in their very early stages of development right now.
So we're still kind of in that clunky phase of quantum computing.
Mm-hmm.
Okay. He also mentioned something called decoherence. What is that?
So decoherence is like,
It sounds scary.
it is a little scary for quantum computing.
Okay.
It's basically when the quantum states get disrupted by their surroundings,
Okay.
and that causes them to lose information.
Okay.
And
Yeah.
it can lead to errors in the computation.
So is it kind of like if you're building like a house of cards
Yeah,
and then like somebody bumps a table
exactly.
and then the whole thing falls apart?
Yeah, it's that fragile.
Wow.
Yeah.
So it's really difficult to maintain these quantum states.
Yes. And so researchers are working really hard on that right now to try to figure out how to overcome this.
So that's the hardware problem.
Yeah.
Are there any other like roadblocks that we need to be aware of?
There's also the mathematical and algorithmic barriers, because you have to design algorithms that can take advantage of these quantum properties.
Okay.
And it's really complex
Yeah.
because it requires a deep understanding of both quantum mechanics and computer science.
So it's really its own field.
Yeah.
Like it's not just quantum mechanics. It's not just computer science.
It's kind of like both.
It's like you need people who can do both.
Yeah, exactly.
Yeah.
And then there's also the challenge of integrating these quantum algorithms with existing AI systems. It's not like you can just plug them in and they'll work.
Right.
It's more complicated than that.
So this is not like plug and play.
No.
Okay. So we got the hardware challenges. We've got the algorithmic challenges. Is there anything else we need to be thinking about?
Schneepat also talks about quantum neural networks in his essay.
Ooh. Okay. What are those?
So those are basically a hybrid between neural networks we use in classical AI and the quantum world.
Okay. So this is where things get really crazy. Okay. We'll have to talk about those next time.
Okay.
This has already been a lot of information.
Yeah.
I feel like I need to take a break and process all this.
Yeah, me too.
Okay.
Yeah. But it's very exciting.
Yeah, I'm really excited to talk about quantum neural networks next time.
Okay, yeah, me too.
Okay, cool.
Sounds good.
So quantum neural networks.
Yeah.
We left off talking about those.
Okay, yeah, so these are like really fascinating. It's basically like taking the brain power of AI and turbocharging it with quantum mechanics.
Okay, so what kinds of problems can we solve with these things?
I mean, anything that has massive amounts of data
Okay.
and complex patterns. So maybe analyzing financial markets
Okay.
or predicting weather patterns or even like cracking encryption codes.
Ooh, that sounds intense.
Yeah, like things that would take normal computers like years or even centuries to do.
So these are like really hard problems,
Yeah.
but a quantum neural network could potentially solve them.
Yeah, a lot faster.
Okay, but how do we even build these things? Like, we've already talked about how hard it is to just build a quantum computer.
Right.
Like, how do we go from there to like a quantum neural network?
So you're right. Training these quantum neural networks is also a challenge.
Okay.
Because like the traditional methods for training, like classical neural networks, they just don't really translate to the quantum world.
Okay.
So Schneepat talks about the need for new algorithms and techniques.
Specifically, he mentioned something called variational quantum algorithms, or VQAs.
Yeah.
What are those?
VQAs are a family of algorithms
Okay.
that are specifically designed to work with quantum computers.
Okay.
So it's kind of like a set of instructions
Okay.
that tells the quantum computer like how to manipulate its qubits in order to solve a specific problem.
So if we go back to like the dog training analogy for reinforcement learning,
Yeah.
like would the VQA be like the set of commands that you use to teach the dog a new trick?
Yeah. I like that.
Yeah, it's a good analogy. And just like training a dog, it takes a lot of time and patience to like optimize these VQAs and to train these quantum neural networks.
So we're still figuring it all out, basically.
Yeah, very much so.
Yeah.
But the potential is huge. Schneppat's essay does a great job of laying that out.
Okay, so this has been a really fascinating look at QRL so far.
Yeah.
But as we're getting toward the end of our dive here, I just want to make sure that our listeners are walking away with like the key takeaways.
Yeah.
So what are some of the things that you hope people remember from our conversation today?
So I think the biggest one is just that quantum reinforcement learning represents a potential paradigm shift in how we approach artificial intelligence.
Okay.
It's still early days, but it's got huge potential for solving some of the world's most challenging problems.
Yeah, I think that's a really good point. We've talked about how QRL could revolutionize everything from logistics to drug discovery, and all of that is super exciting.
Yeah. But I think it's also important to remember, like Schneppat reminds us, that we need to be realistic about the challenges.
Yes, absolutely.
Like, we still need to figure out how to build stable quantum computers, and we need to develop these new algorithms to make them actually work.
Yeah. It's a very long road ahead of us.
Yeah. But it sounds like it could be a really exciting journey.
It is, yeah. Full of innovation and discovery.
So I guess the future of QRL depends on, like, collaboration between experts from different fields.
Right, yeah, like quantum physics and computer science, all sorts of fields. And as Schneppat points out, we need to be mindful of the ethics, too.
Yeah, that's a really good point. Like, we need to make sure that we're developing this technology responsibly. Okay, so before we wrap things up completely, do you have any, like, final thoughts that you want to leave our listeners with? Like, anything that you want them to be pondering after they finish listening to this deep dive?
Yeah, I think going back to Schneppat's essay, his concluding vision is really interesting.
Okay.
Where he talks about, you know, the potential for QRL to lead to, like, a completely quantum-controlled intelligence.
Okay, so this is like AI that is actually run by a quantum computer.
Yeah, exactly. And, like, what does that mean for humanity? Like, that's a big question.
Yeah, that is a really big question. Like, that goes beyond just the technology itself.
Right.
That's like a philosophical question almost.
Yeah, exactly. It gets into the nature of intelligence and consciousness.
Right.
And, like, our role in all of this.
It makes you wonder if this could be the path to, like, a truly general artificial intelligence.
Yeah, it's a very exciting possibility, and one that I think we need to approach carefully.
Yeah, with both, like, excitement and caution, I guess.
Yeah, for sure.
Well, I think that's a great place to leave it.
Yeah.
So if you want to learn more about this, we highly recommend checking out Yogo Schneppat's essay, QRL, Quantum Reinforcement Learning for Intelligentic AI. It's a really great overview of this whole field.
It is.
And as always, keep learning, stay curious, and we'll see you next time for another deep dive.
See you then.
Okay, so we've made it to the end of our deep dive into quantum reinforcement learning, or QRL. We've been following along with Yorgo Schneppat's essay, QRL, Quantum Reinforcement Learning for Intelligentic AI. It's been a wild ride, for sure.
Definitely a lot to think about. Schneppat has given us a lot to unpack here. What are some of the key things you're walking away with?
Well, I think the biggest one for me is just how powerful this combination of quantum mechanics and reinforcement learning could be.
Yeah. It's like we're taking two incredibly complex things and we're putting them together.
And somehow that's leading to something that could potentially change the world.
Right. Yeah. I mean, think about all the applications we talked about.
Like optimizing logistics and supply chains.
Or designing entirely new drugs.
Or even creating self-driving cars that are actually safe and reliable.
It's mind-blowing. But, like Schneppat keeps reminding us, we have to be realistic about the challenges.
Right. Those quantum computers are still tricky. They're not exactly ready for prime time.
Yeah. They're still in their early stages of development.
Like, we're still in that phase where the computers are the size of rooms.
Exactly. And they're incredibly fragile.
It's that whole decoherence thing, right, where the quantum states get disrupted.
Yeah, that's a big one. And then, of course, there are the algorithms.
We need those special algorithms that can actually harness the power of these quantum computers.
It's a whole new way of thinking about programming. And then there's the ethics side of things.
Right. We can't just forget about that.
Schneppat really emphasizes the importance of responsible development.
Like, we need to make sure that these algorithms are fair and unbiased.
And that we're using this technology for the benefit of all of humanity.
Okay, so, big picture. What's the one thing you want our listener to take away from this deep dive?
I think it's that quantum reinforcement learning has the potential to be a game changer. It could revolutionize so many aspects of our lives. But we're still in the early stages. It's going to take time, and it's going to take a lot of careful consideration.
Yeah, it's a really exciting time to be following this field. So much is still unknown.
Exactly, and that's part of what makes it so fascinating. If you want to dive deeper into all of this, Schneppat's essay is a great place to start.
Yeah, QRL. Quantum Reinforcement Learning for Intelligent AI is definitely worth a read. It's a very clear and thought-provoking overview of this whole field.
Definitely check it out.
Well, on that note, we'll wrap up this deep dive. Thanks for joining us, and keep exploring the world of knowledge. Until next time, happy learning.